Hello everyone, this is Zubair Ahamad, studying BE Computer Science and Engineering at CSE Institute of Technology. In this video, we are going to see about support vector machine algorithm. So first of all, we should know what is a support vector machine. A support vector machine is a supervised ML algorithm that performs classification or regression takes by constructing a divider that separates data into two categories. The optimal divider is the one which is equal distance from the boundaries of each group. The algorithm is more commonly used for classification than regression. In some articles, the SVM for regression is also called vector regression. So, how does the support vector machine classifier work? SVM works by mapping data to high-dimensional feature space so that the data points can be categorized, even when the data are not otherwise linearly separable. A separator between the categories is found, then the data are transferred in such a way that the separator could be drawn as a hyperplane. Following these characteristics of new data can be used to predict the group to which a new record should belong. For example, consider the following figure in which the data points fall into two different categories. These pictures are the example for support vector machine. And now the types of support vector machine. There are two types of support vector machine. The one is linear SVM and another one is non-linear SVM. So what is linear SVM? Linear SVM is used for linearly separable data, which means if a dataset can be classified into two classes by a single straight line, then such data is termed as a linearly separable data, and classifier is usually called as linear SVM classifier. What is non-linear SVM? Non-linear SVM is used for non-linearly separated data, which means if a dataset can be classified by using a straight line, then such data is termed as a non-linear data, and classifier usually is called as non-linear SVM classifier. And now we are going to see about hard margin versus soft margin in a support vector machine. So what is hard margin? The hard margin means that the SVM is very rigid in classification and tries to perform extremely well in the training set, covering all available data points. And what does a soft margin mean? The idea behind a soft margin is based on a simple assumption: allow the support vector classifier to make some mistakes while still keeping the margin as large as possible. So now we are going to see about application of SVM. What are the applications of SVM? Computational biology, steganography detection, face recognition, text categorization, image classification, and handwriting recognition. These are the applications of support vector machine. So first of all, we are going to see about computational biology. The detection of protein remote homology is a common issue in computational biology. In recent years, SVM algorithms have been extensively applied for solving this problem. And now we are going to see about steganography detection. With the help of SVM, you can tell whether a digital image has been altered or contaminated. The algorithm can be unauthorized data and watermarks illegally embedded into official documents. And now face recognition. The SVM classifier divides the element of image into face and non-face categories. First, it is imputed training information for n cross n pixels. Then it separates the features of each pixel into the factors for non-face recognition. And now text categorization. Using training data, the support vector machine classifies document into many categories, including news, stories, emails, and web pages. And image classification. SVMs can classify image more accurately compared to traditional query-based refinement. So now we are going to see about advantages of support vector machine. Resilient to overfitting. Except for the points closest to the plane, most of the remaining data becomes redundant. When working with the boundary points, we can intentionally allow some outliers to be misclassified to see the big pictures and determine the optimal hyperplane. Simplified calculation. Once the hyperplane is built, we can assign a class to data points located in classified area without the calculated distance between each point. These are the advantages of support vector machine. And now, the SVM algorithm doesn't work well in the following situations. What are the following situations? Means the dataset contains a lot of classes, the dataset contains a lot of noise, the target classes overlap. In these following situations, the SVM algorithm doesn't work well. So these are all about the support vector machine. Thank you.